Okay. Yes, my name is Thomas Gerberding and I'm working for the company who delivers these dam and all the stuff here in Harz Mountains. It's the Harzwasserwerke, and we have three things to do, important things to do. The first is to catch all the high waters in these barrages and dams. The second is water supply. And the third is to give the water in a special amount down the hill, down the valley, to fill up in periods where when it's really dry. I think another number is 340,000 cubic meters of concrete. It's 8 or 9 meters thick on the top, and I think 11. I don't know. Really, we can have a look over there if this is important to you. And the bottom. We have two outlets. One of it you can see when you look down the wall of the dam. There is the bottom outlet for the high water, and the other one is well, right over there. It starts in a tunnel. And the tunnel goes through the hill over there, down to the power station. Yes, well, okay, so far to here. Maybe you have questions, so you don't understand something I'm talking about, maybe because of loudness or maybe because of understanding, just ask please. I'm doing these tours maybe twice or 3 times a year, so I'm not very used with this, and sometimes I forget something.
Yeah, why it's been decided to build an arch dam rather than a straight wall? Is there any particular technical reason or something?
Yeah, it's a good question. I don't know really, but I think it's because of the
Geology, okay.
geology of the valley here.
Okay.
It's a massive rock.
Mm-hmm.
It's very hard.
Okay.
And so it's possible to get all the pressure of the water coming through this arc dam down in the hills, down in the rocks in the mountain.
Okay.
And it was the easiest way, maybe even the cheapest way.
Cheap.
And also very safe.
Okay.
Second.
Thank you. What was the second question?
Outlet required in the
Yeah.
Oh, you have some questions?
Yes, we do have some questions for you, sir, today.
Which is the next?
So obviously, we're not going to ask you everything in one go.
So, yes, please, we have a look over there.
Okay.
So we're going to other side of the dam.
Today it's 67%. 68% filled with water. It's quite normal for this time at the year, because in the winter, the autumn and winter time, it fills up, and in summer, well, it goes down to a low level. Last year we had a very, very dry summer, and so it was a historical low. It was about 23%, so it was nearly empty, we would say. But we had some floods in the time from 21st of December till the middle of January, so it was filled up to I think 70%, and today it's 67, 68%. So when it's filled up to 100%, what will happen? What will you say? What will happen? There's a spillway, right? And we're standing on the spillway. It's a special type of spillway. It's built in concrete underneath us, and it's a kind of siphon. It's a siphon effect. So the water comes up to a level higher than the 100%, and going down through like a tunnel, like a pipe, underneath the level of 100%, and that means there's a siphon effect which draws the water through this, and there's rising up the speed. So it's getting more through this pipe than normally you only build a normal pipe going by gravity through it. This siphon effect, beschleunigen, was heißt beschleunigen?
Accelerate.
Accelerate.
Yep.
Yes, thank you. Accelerates the water, the speed of the water. And we have 8 of these pipes in different heights, in different level. So when it starts about 3 cubic meters per second going through this, and then I'm not sure, well, all the numbers, it's about 20 or something like that can go through. And the other thing is, down there you have the bottom outlet with a big valve. It's about 1.2 diameter, and this means also when it's filled up, well, I would say to 50 to 20 cubic meters. Well, here we have my colleague. He's
Good morning.
master of this part, Mr. Himstedt. So we thought it was starting at 10 o'clock, so this is the time for his arriving here. Also, willkommen, ja, wir haben ein bisschen früher angefangen. Guten Morgen. Der untere Grundablass, wie viel, wenn 100% gefüllt ist, wie viel? 16, okay. I was nearly right. 16 cubic meters when it's filled to 100%, and we open the bottom outlet to 100%. That means 16 cubic meters per second going out there. Wir wollen jetzt in das Schieberhaus da mal reinfahren. Ins Windenhaus. Genau, ins Windenhaus. So the next step is over there. We call it Windenhaus. As you can see, there's a kind of railway down there, and on this railway there's a massive plat of concrete, and this we can draw down to the tunnel. The tunnel is I think 40 meters deep there, and it goes through the mountain to our power plant. And with this massive concrete plate we can close this tunnel and dry it and get the water out for an inspection, for example, or for something maintenance or other stuff. And so this is the main reason for this. But it's quite interesting because we have the technique of the 50s over there, and it's still working.
So we are going to see something. Here is kind of, I don't know what it's called. This is first electricity wheel we have. A motor with the chains. Yes.
We have one. And one big turbine. I will show you.
So you can see inside here. So this is
that's something from 1950s somewhere, I don't know. And it's still working. Well, it's working with the electrical motor, yes, and with a brake here. But it also can be pulled with the muscle power. And that means through this cable we get this plate on the tunnel underneath there to close it. For example, the valves in the power plant is not closing, or the turbine is going through, or something happens. Someone has to come up here and get this plate down for safety. And the other thing, the normal thing would be twice a year, I think. Twice a year, I have to ask my colleague. We close this tunnel and have an inspection. That means the water gets out, yes, well, but it's not really dicht. So it's little water is coming through this sealing of the plate, and it's not a nice job to do, to go in this tunnel. But, well, the tunnel is 2 meters of high. The diameter is nearly 2 meters, I think. You can have a look down the right number. And well, the water is going through this, and then the tunnel is going into a pipe, and the pipe is going down to the power plant. Yes. Well, this is quite in a good shape because of good maintenance my colleagues do here. We decided to build it new, but it would be very, very expensive, and so this is quite in a good shape, and everything is in a good function, and we decide to keep it. And you can see everything. What happens here? For example, all the wheels and the cable. Okay. So. Yes, this is the 2 parts we can see here. Wie häufig gehen Sie in den Tunnel?
Einmal im Jahr.
Once a year. Okay. Once a year we have the inspection to the tunnel. Okay. Well, we don't have so much people working here anymore. The people who are going to retirement, there's nobody coming, and it's all the same. The number of people working is getting lower. Well, okay, some of the electricity is over there because of the machines, and everything is here. Just to show. Okay, so next step will be in the inspection tunnel. Oh, you have some questions? Well, it's very small, so we don't have a chance to speak a little bit, or so just one after the other we have to go through. Well, you can see special things. You can see the well, how it's called, the control tunnel. You can look down to the bottom. Because there are I think 5 parts of the dam coming here together as not being connected with each other. It's just a ceiling in between. So that means when the water comes with its pressure, it presses these parts into another and keeps the ceiling, and so there's no water coming through. And you can see these parts. Well, it's all of concrete, and the ceiling is, I think it's copper. Well, what can you see on the other hand? Well, on the outside there's a pipe, and it's because of the rain here on this road. We collect it and give it through this pipe down. And at the end of the control tunnel, control way, you see a small waterwork that is some well, it's a filter, and there are some pumps, and we clean the water out of the dam. For this small building over there, there's a small restaurant, and this is the water supply for the restaurant over there. And inside we have a filter of Calciumcarbonat, ne? Also eine Jura-Perle. Wie ist das auf Englisch?
Calciumcarbonat.
Yes.
But it's a natural.
It's a natural material, yes. It's a grade, and the water going through the particles, they will keep the filter will keep these particles, and there's an Einstellung des pH-Werts. So the pH is at a special point. I think it's pH 7.5. Well, I don't know really, but it's a small waterwork. Yes. Okay.
Because,
maybe you have some question. Maybe you see this and say, "Aha, okay, I know what you mean," and maybe not, and so you have some question afterwards. So we go through this tunnel.
What's that? I don't know.
yes.
We are going through the tunnel. It's a quite narrow path. So our instructor is opening the door, as you can see. It's such a beautiful view, as you can see, down the valley. Look at that, everything is in order. It's a tunnel, we are going through it, so you can hear the voice of water, and we have pipes, this is outlet. It's quite scary. As you can see, that's the outer view. Such a marvelous structure. Masterpiece of civil engineering.
Das war der Powerpoint, wo er reingelassen hat. Also ich glaube, wenn hier nur einer da rein ist, das ist glaube ich schon zu wenig. Muss glaube ich schon öfters kommen. Dann siehst du irgendwie überall.
It's quite a long tunnel we are passing through. So this is, I think, the electricity wires, or I don't know, I'm not too sure. I think the guy will explain to us in a minute. So that's the breakers. It's quite noisy here. You can see it's a little bit dark as well. It's an unfinishable path we are on. I think it's going to finish now. Yeah, it's going to end now. This tunnel is going to end. Oh yes, it's about to end. Ah, okay. Yes, ending part, I think. Thank you. So these are some kind of tanks, valves. Yes. This is the exit of the tunnel. Yes, we are out. Yes, we are out of the dam. People are still coming out of the tunnel. Here we have Norma. She is taking some pictures as well. Some kind of instruction going on in Deutsch.
Yes, that's it. Well, we call it Juraperle. I don't know the English expression, so I'm sorry. Dolomitisches Material. Well, it's the other expression for it. Well, maybe you recognized nearly at the in the first part of the control inspection tunnel, there were some openings on, well, it was closed, but you could open. And this was the pipes, to inspect the pipes of this siphon effect of the spillway. So, what's the reason to do to build a spillway? Well, the first thing is to have a not really control, but to have a look at the water going over. When there's no spillway, it would go over the complete dam, or somewhere you can't manage and you can't control. So when there's a flood coming and the reservoir is getting higher in its level, we start with the operating time of the turbine at first. We make electricity and sell it. 100%, 24 hours a day and so on. And maybe that's not enough. So the second step would be, so the turbine, I think it's 3 cubic meters per second. Well, I don't know really. We have a look and we ask my colleague. The second step would be to open the bottom outlet. And as you know, he said it is 16 cubic meters per second when we open it and the reservoir is filled to 100%. And when that's even not enough. And that could be when there's a flood which comes every 100 years or maybe every 200 years by statistic, the spillway is working. Yes, the spillway is working. And well, in my time, I'm working 27 years for the Harzwasserwerk, and it happened twice in these 27 years. It was very special, so every colleague came here to see, oh great, yes, I saw it. It's not our decision. Our decision would be not to, for not operating of the spillway, because it's not, we can't control it. It's just happening, and we can't control the water at that point. Giving it through the turbine or giving to the outlet, we can have a control. We can lower it or high it up to 100%. But the spillway, this is without any control. Yes, that's the reason. And how many pipes? Well, this would be the statistic. Well, how many floods per year, which is the highest flood in 100 years, which is the highest flood in 1,000 years. I think in 2017 we had a flood which was happening every 200 years. Unsere Flut 200 Jahre, ne?
Ja,
200-jährige Achso, die Turbine wollte ich noch fragen. Die Turbine hat, wenn sie 8 Kubik? Oh, okay.
Maximale Öffnung.
Maximum at the turbine is 8 cubic meters per second, not 3. 8 cubic meters per second.
What type of turbine?
It's a Francis turbine. Francis turbine. Francis, what we call it, Francis.
Yeah.
German.
I think it's the same.
The advantage for Francis turbine?
Pardon?
Advantage.
Advantage.
Vorteil.
Ah, okay. It's because of the different levels we have in the dam, in the reservoir, and it's still working at a good efficiency. Even when you have it filled with 35% or 100%, we have a very good net efficiency, effectiveness. That's the right word, I think. Because the turbine is, there are some Schaufel. So there's the wheel with the Schaufel. Oh, it's called in English. Schaufel? Okay. And there are
No.
no.
That things is water going inside and it is going around. Yeah?
Yes.
Ah,
It's
okay.
like a pump, like a pump. There's some
Yes.
Centrifugal pump,
and
probably.
Yes, and it's working. And on the outside we have the there are some small walls, I don't know the English expression, which we can give in the angle. And depending on the height and on the pressure we have for the turbine, we have a different angle for these stuff before the turbine. So we can give always the best point of effectiveness for this special level of the dam, of the reservoir. Sorry. So is it clear? Well, I don't know. Well, it's the best type for this special thing.
And right now, what is the efficiency of turbine?
Was für eine?
92% circa.
Okay, 92%. 92%.
Which are the advantages of this type of turbine?
Okay, the Francis turbine? No? Okay, some other question?
Yeah,
Yes.
the annual electricity for the year for turbine.
But
Annual electricity.
yes, in last year it was 10.7 million kilowatt hours. I think yes.
For 3 months. Or
Letztes Jahr hatten wir 10,7
Kommt hin, ja.
Millionen Kilowattstunden. Okay. In the whole year, 2018, yes. 10.7 million kilowatt hour. So in total we have with our 11 turbines. Last year 28 million kilowatts hour. Yes. Well, so this one is a big one, yes.
Excuse me, sir. What arrangements do you have in case of any breakdown or something? I mean, if you damage something somehow, and how you gonna, how you gonna fix it up? For example, if you have high pressure at the same time, and you break down something, you have some kind of damage. How you gonna tackle that issue? Or maybe you never have such type of experience?
No, we don't have.
Okay. Do you have any arrangements? Let's say, do you have any arrangements for that?
Well, we have. There should be a safetyness. The factor is 2. Well, here we have the turbine and
Okay.
we have the bottom outlet.
Okay.
These are the 2. And on the other dams we also have normally 2 bottom outlets. So when the one is closed, for example, the valve
Yes.
at the bottom outlet is not working anymore, everything goes through the turbine.
To the
And there's
turbine.
a way beside the turbine.
Besides the turbine as well. Okay.
So there always should be 2 ways.
2 ways. Okay.
And well, we have this monthly inspection, and once a year we have the tunnel visiting, and all the stuff.
Basically, got an eye on
and
it. Basically.
his colleagues, they are. Well, this is the main thing to do for them, the maintenance of all that stuff.
That's good. Thank you.
Well, something can break, yes, but there's a risk management, and so well,
At the same time, you should have method statement as well.
yes.
Okay, for that. Okay. Thank you.
No, creo que no, pero pregunta. For which return period is it designed for, the dam?
The design of the dam, the period.
The return period,
When it was built.
Yeah, when it was built.
1952 to 1956.
No,
Yeah,
no.
but the design, the design.
Like,
For,
how many years will be in the
I mean,
no, I was
Yeah,
asking.
you designed the dam for how many years?
the life of this dam, basically.
No, I know. Well, we don't know. Maybe 1,000 years. I don't know. Because of good maintenance, it will last very long. And there's no plan for renew it as total.
Okay.
Just every year we do something. For example, the ceiling between these 3 or 5 parts, we are fixing the ceiling. We fixed one, I think the year before last year, and one is this year or next year, I don't know. Diese Dichtung, die wir da so machen wollten.
Die provisorisch, die jetzt provisorisch
Genau.
gedichtet ist, die ist die
Provisorisch.
nächsten 5 Jahre angedacht.
In the next 5 years we do this again, the ceiling. So this means high costs, yes, I don't know, 200,000 or 300,000 euros. And with divers, we have to do this from the water side. It's not possible to go from this side and all that. So every time we do some maintenance. So we hope it will last
Forever,
more
Paro.
than 100, more than 200 years. I don't know. Yes.
Okay. Yeah,
Okay.
that's it, I think.
So next step would be the power plant. That's you have to do a small walk because the bridge is I think the bus is not going over the bridge. It will break.
Okay.
I mean the bridge will break.
Let's go to the next step, power plant.